All right, number 4 is very similar to number 3. This time we have an area of 8. So that means it could be a 1 by 8 rectangle. It could be a 2 by 4 rectangle, and that's really our only whole number possibilities. So I'm going to draw both of these. If it's a 1 by 8 rectangle, if I add up the 4 sides, I get 16, 17, 18. That's not right. If it's a 2 by 4 rectangle, and I add up the sides, 4, 8, 9, 10, 11, 12. There we go. So I must have a 2 centimeter by 4 centimeter rectangle. All right, number 4, we transition into some trig. We do have a right triangle, but we only know one of the sides, so we can't use Pythagorean theorem. Working off this 39-degree angle, the side that we know is this hypotenuse. I can tell it's the hypotenuse because it's across from the right angle. The side that we need is attached to the angle that we're working with, which makes it the adjacent. And if I go through sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, cosine's my winner here because I'm working with adjacent and hypotenuse. So the equation I'm going to write is the cosine of something, specifically the cosine of 39 degrees is going to be adjacent on top, hypotenuse on bottom. Adjacent is x, hypotenuse is 10.1. So to get the x by itself, I'd have to multiply both sides by 10.1. If you punch 10.1 times cosine of 39 into a calculator, you should get right about 7.8. Now, if you're getting something different, it might be that your calculator is in what they call radian mode instead of degrees. So usually there's a DRG button or a mode button. Hit that and see if your D, degrees, is highlighted or if your R, radians, is highlighted. You want degrees to be highlighted. Number 6 is very similar. We're going to use trig again because we only know one of the side lengths. This time, the side that we know is across from the angle we're working with. That makes it the opposite side. The side that we need is the hypotenuse. It's across from the right angle. So going back to sine, cosine, and tangent, opposite and hypotenuse, we find those in with sine. So I'm going to write a sine equation. Sine of a 28-degree angle would be the opposite goes on top. The opposite is 12.5. The hypotenuse goes on bottom. The hypotenuse is our x. So now we have a variable in the denominator. So I'm going to multiply both sides by x to get that variable out of the denominator. Now I'm trying to isolate the x. I've got it attached to the sine of 28. So I need to make that multiplication of the sine of 28 go away. So I'm going to divide by the sine of 28 on both sides. So when all the dust settles, I get x by itself on the left, and I get 12.5 on top and sine of 28 on the bottom. That's a division problem. 12.5 divided by the sine of 28. If you punch that into a calculator, you get about 26.6. In number 7, very similar. Again, we're working off this angle here. We only know one of the sides of the right triangle, so we're probably going to have to use trig. The side that we know in this case is attached to the angle. That makes it the adjacent side. The side that we need is across from the angle. That makes it the hypotenuse. So adjacent and hypotenuse, they show up with tangent. Tangent is opposite on top and adjacent on bottom. So I'm going to do tangent of 51 degrees is opposite on top, that's my x, and adjacent on bottom, that's my 8.7. So the x is being divided by 8.7. That means I'll need to multiply both sides by 8.7 to get rid of it. And if you punch 8.7 times tangent of 51 into a calculator, you get about 10.7. And the nice thing is once you know that, you can use that to get the area of the triangle very quickly. Remember from before, the first side, area of a triangle isn't just base times height. Base times height is what you use to get a full rectangle. A triangle is only half of that. So you do base times height and then cut your answer in half. We know, I guess we could call the 10.7 would be the base. The perpendicular distance, the 8.7, would be the height. Divide by 2. If you punch that into a calculator, you should get pretty close to 46.5. Now our label, since these were both in meters, I guess I could have called that meters. Since these are both in meters, we're doing meters times meters, and that'll give us meters squared. Square meters, that's what you always get a square unit when you're measuring area. Hope that helps. If not, please contact me with questions. You know where to find me.